All right, here's my fourth and final video covering section 3 of the second practice test, the second redesign practice test. Section 3 is the no calculator section, and so in this video I'm going to do questions 16 through 20. So here's 1 through 5, which came from a previous video. Similarly with 6 through 10 and 11 through 15. So I'll pick this up here on number 16, where I'm going to start entering my answers, so I'm no longer multiple choice. So for 16, the sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses awarded? Okay, so lots of possible answers here. The way I think about it is if you have 3,000 total to give out, that's 3 of these 1,000s, and I choose to break it up into 3 different 1,000s because 250 and 750 sum up to 1,000 really nicely. So what I could do is kind of give out the money this way. Well, I give 3 people 250 and 3 people 750, and I'd be guaranteed to be giving out 1,000 3 different times. So what is one possible number of $250 bonuses awarded? Well, one possible number is 3. I could sit here and tell you all the possible answers, but I don't know that that's really relevant or a good use of your time. So there's one way you could solve this problem. Moving on. Number 17 here. It looks pretty impressive mathematically. It's really not that bad. You're told that this sum equals this. A, B, and C are constants. It's true for all values of x. What is the value of b? The way to solve a problem like this is to write this side so that it looks like this side. What do I mean looks like? Distribute that 2x through. That gives you 6x squared plus 10x. Distribute that 5 through. That gives you 15x. Sorry, that's a 3. That gives you 9x plus 15. And if you combine like terms, you get 6x squared plus 19x plus 15. If that is equal to ax squared plus bx plus c for all values of x, what that means is that the a times x, the a has to be equal to 6, the b has to be equal to 19, and the c has to be equal to 15. So when it asks you what is the value of b, well, the b is just equal to 19. 18. You're given these triangles and you're told that AE is parallel to CD. These two lines right here are parallel. These lines cross right here. When you have lines crossing, they're exterior angles, I think that's the right terminology, are congruent. In other words, those two angles are the same. When you have parallel lines and a line going through them, their alternate interior angles, I think that's the right terminology, are the same. So these two angle measures are the same. And by the same logic, these two angle measures are the same. So what I have are similar triangles. I have that BAE is similar, which I think you write like this, to, and then be careful here. Up here I went from 1 to 2 to 3 hash marks. So here I'll go 1, 2, 3. It's similar to BDC. So what that tells you is that length AB, the first two letters, will be proportional to length BD. And it also tells you that length EB, the first and the last two letters, is proportional to BC. And P for proportional. You could write times some number equals that, but I'm not going to bother. Okay, so what does that tell you? If this line segment, this length here, is double this one, then this one right here must be double this one. This must be 4 right here. So maybe writing this just confused people. But the reason I really wanted to make this to stress this is you don't look at the ratio between the 8 and the 5 and say that's the same as the ratio between the 10 and the 4. You have to use the sides that correspond. So it's the ratio between 10 and 5 that has to be equal to the ratio between 8 and this number, which turns out to be 4. But don't put in 4 for your answer because it doesn't ask you what is the length of CB. It asks you for the length of CE. So that's 4 and 8 more. My answer would be 12. 19. In the xy plane, We have a circle centered at the origin, and the measure of this angle right here is pi over a radians. What is the value of little a? So how many radians do I have right here? So the question is figure out this angle right here in radians. And all you know is this one point here, so you're going to have to know a little bit of trig. And specifically what we're going to do with the trig is recognize that this is not a unit circle. That this point, root 3, comma 1, does not lie on the unit circle. Its x-coordinate here is greater than 1, for example. So it can't be on the unit circle, a circle with radius of 1. So what is the radius of this circle? Well, you can figure out the radius using the distance formula. The change in the x-coordinates here is the square root of 3. And the change in the y-coordinates is 1. So root 3 squared plus 1 squared must be equal to your distance squared. All I'm doing is using a little Pythagorean's theorem there and recognizing that this is root 3 and this is 1, and I want to figure out c. So what I end up getting is that c is equal to 2. So my circle here has a radius of 2. So I can scale my circle to draw a unit circle. So instead of having this radius of 2 and this point that I'm interested in, I could draw a different circle that has a radius of 1. And then this point right here, instead of being square root of 3 comma 1, would be half of those numbers, root 3 over 2, 1/2. So then you got to think back to trig and be like, okay, what angle, the sine of this angle gives me the y-coordinate, and the cosine of this angle gives me the x-coordinate. So I don't know, choose whichever you want, sine of what equals, let's see, sine is the y-coordinate equals 1/2. And you think on your unit circle, the value that x would have to be is pi over 6. The sine of pi over 6 is what equals 1/2. So this angle measure right here is pi over 6, which is not the answer you want because it wants to know what a is equal to. So a is equal to 6. Lastly, number 20 here, you're given a system of equations. You're told that a and b are constants, and the system has infinitely many solutions. Okay. The way to think about this is that for a system to have infinitely many solutions, these two equations must represent the same line. So 2x plus 8y equals 60 represents some line. And you could probably think about it long enough and figure out what line that represents. But frankly, I don't care what line that represents. I'm not going to use this graph or anything. But it represents some line. If this represented a different line, then their point of intersection would be my only solution to the system of equations. If it represented a parallel line, then there would be no points of intersection, so there would be no solutions to this system of equations. But what it's saying is it has infinitely many solutions, so my second line must fall right on top of this first line in order for any point on this line to be a solution. This must be the same line as this. So what are a and b, or specifically what's a divided by b, if this line is the same as this line? Well, the easiest way to figure it out is to scale the first line by 5. Instead of ax plus by equals 12, I could write 5ax plus 5by equals 60. All I did is I multiplied both sides of the equation by 60, but the reason I did that is because then I'd have a 60 here and here. And so if this equals 60 and my bottom line equals 60, I got 2x plus 8y. So what I have is that 5ax plus 5by equals 2x plus 8y. So then you're supposed to figure out what a and b must be equal to, kind of like we did in this problem. We can set the different coefficients equal to each other. I can say, well, all right, 5a has to be equal to 2, and 5b has to be equal to 8. So a would have to be 2/5, and b would have to be 8/5. And if I take those two numbers and I divide them, if I figure out a over b, because that's what the answer was, the question was asking for, I get this mess. But if you multiply the top and the bottom of this fraction by 5, or maybe another way to say that is if you change this division of fractions problem into a multiplication of fractions problem by multiplying by the reciprocal of the denominator. So flipping that guy upside down, then these 5s will cancel out, and you'll get 2/8, aka 1/4, aka 0.25. So either of these answers would work. Put that in there, and then that's the end of this section.